Video 3, VRRP and IP multicast addressing. This video describes tasks for the VDay 1 book, Introduction to Enterprise Routing, that can be downloaded from www.juniper.net/day1. Up to now, you have seen the mechanics of unicast IPv4 addressing. Unicast IPv4 addresses belong to a single host, and they are mapped to a MAC address using the VRRP protocol. Now we move into the multicast world, which follows completely different rules. Like any other IP packet, a multicast packet has a source and a destination IP address. Its destination IP address is multicast. In other words, it represents a group rather than an individual host. However, the source IP address of a multicast packet is not a multicast one. It is the unicast IP address of the host acting as a source. You will often hear the name group when referring to a multicast IP address, since it represents a group of hosts or subscribers that may be connected to the same or to different subnetworks. 224.0.0.18 is just an example of a multicast IPv4 address. The address is reserved in a LAN to all the routers running the VRRP protocol. You will see VRRP in action soon, but for the moment, let's go back to the multicast topic. All the multicast IPv4 addresses have the first 3 bits set to 1. The full range of multicast IPv4 addresses goes from 224.0.0.1 to 239.255.255.255. Unlike unicast, in the multicast world, there is no protocol to map IP to MAC addresses. In fact, there is a fixed mathematical rule doing the mapping. Let's see how it works. All the multicast MAC addresses have the last bit of the first octet set to 1. And this is not only the case of the MACs derived from IPv4 multicast addresses. This bit is set to 1 in order to transport multicast traffic of other non-IP protocols. However, the 01:00:5E prefix is reserved to the MAC addresses mapped from the IPv4 multicast. Then, the last 23 bits of the multicast IPv4 address are copied to the least significant bits of the MAC address, and that completes the mapping. It's not a one-to-one mapping in the sense that several multicast IP addresses can be mapped to the same MAC. But it's very unlikely to see 2 such groups with identical MACs active in the same network at the same time. Let's see how VRRP, the Virtual Router Redundancy Protocol, works. When you configure VRRP at router 1, the router sends an IGMP report for group 224.0.0.18. IGMP is used by hosts to subscribe to a multicast channel. The IP multicast group 224.0.0.18 is reserved for the exchange of VRRP control packets. So router 1 basically lets the network know that it's interested in receiving VRRP packets. Let's suppose that the layer 2 switch supports IGMP snooping. In that case, the layer 2 switch notes that router 1 is interested in receiving Ethernet frames whose destination MAC address is the one mapped from 224.0.0.18. After waiting for a few seconds, router 1 doesn't receive any VRRP packets, so it becomes the VRRP master. As a result, it starts setting VRRP advertisements every second, destined to 224.0.0.18. Inside the payload of the VRRP advertisement, router 1 specifies the virtual router ID and the virtual IP address for which it's claiming the mastership. In this case, the configured virtual router ID is 1, and the virtual IP address is 10.1.1.100. The VRRP packets are sourced from a virtual MAC address that is mapped from the virtual router ID. This IP to MAC mapping follows a fixed mathematical rule that is very similar to the rule you just saw for multicast addressing, with one important difference. These virtual IP and MAC addresses are both unicast. You'll see the rule in action later on. Then router 1 sends a gratuitous ARP request, and the other hosts in the LAN update their ARP cache. Yes, it's an ARP request and not an ARP reply. Then you configure router 2 as a VRRP router with the same virtual router ID and with a higher priority than router 1. At the beginning, router 2 registers to 224.0.0.18, the VRRP multicast group. After some time listening, it realizes that there is already a VRRP master for that virtual router ID, but with a lower priority. So it decides to become the master and starts sending its own VRRP advertisements. As a result, router 1 stops sending them. This effectively moves the virtual IP and MAC ownership to router 2. And router 2 sends a gratuitous ARP sourced from the virtual MAC address. Let's see what an IGMP version 2 report looks like. It's basically an IP multicast packet targeted to the IPv4 and MAC addresses that belong to the group it is signaling. And how about the VRRP packet? The source MAC is the virtual MAC address corresponding to the virtual router ID. You can see how the mathematical rule works. The virtual router ID is added after the prefix 00:00:5E:00:01. Note that it's a unicast MAC address because the first octet is all zeros. The destination MAC address corresponds to 224.0.0.18, the multicast IP address reserved for VRRP control packets. And the rest of the fields are easier to understand.